This will be part 1 of lesson 3, and lesson 3 is on page 157 of your student workbook. Lesson 3, really big lesson. It would probably take, if we were in class, 2 full days to go through this lesson. There's 2 corresponding videos that you're going to watch from Mac Prima, so videos 224 and 225. If we were in class, this first page I would discuss with you and I would get you to star. So this first page is a review of the first 2 lessons and all of the concepts in the first 2 lessons, and just a ton of material in those first 2 lessons. So star this, and I would say like these are your notes. I'll talk about a few things. Okay, let's actually jump down to here. So remember that in lesson 2 we did the cast rule. And according to the cast rule, what that shows you is wherever your terminal arm lands, whichever quadrant your terminal arm lands, this is the trig ratio that would be positive in that quadrant. So if I had a terminal arm that landed in quadrant 2, I am in what's called the sine quadrant, and the only ratio that's positive in quadrant 2 is sine. So if I gave you, let's say, 150 degrees, which would terminate in quadrant 2, sine would be positive, cosine and tangent would be negative. Okay, so that was the cast rule. This is talking about reference angles. So remember that a reference angle, when I draw an angle in standard position, so that would be my angle in standard position, or we call it a rotational angle. You could always make an acute triangle by drawing a point on your terminal arm and then a vertical line to the x-axis. You will always get an acute triangle, and this would be your reference angle in quadrant 2. In quadrant 1, so quadrant 1 is sort of special because in quadrant 1, if I was to make my triangle, so here would be my triangle, the reference angle is equal to the rotation angle. So if the reference angle, let's say this was 70 degrees, and I said, well, what's that rotational angle? It's also 70 degrees. In the third quadrant, so if I was to terminate in the third quadrant, and let's say that was 210 degrees, draw your acute triangle. So that would be my acute triangle. And if I said, well, what's your reference angle? The reference angle would be this angle here. And in order to calculate that reference angle, it would be 210 degrees minus 180 degrees. Quadrant 4, let's draw a rotational angle in quadrant 4. So that would be my rotational angle. My triangle in quadrant 4 would be, there's my acute triangle. That's my reference angle. One complete rotation around a circle is 360 degrees. Let's say this terminated at 330 degrees. And I said, well, what's that reference angle? 360 minus 330 is 30. And then the last important piece of information from this would have been lesson 2, were the 3 primary trig ratios, and we no longer use SOHCAHTOA anymore. What you are to memorize is that the sine of theta, because remember that now we could draw triangles in quadrant 1. This is x, this is y, and that's my radius. So if I said, well, what's the trig ratio for the sine of theta? Sine of theta is 7 yellow rabbits. And if you memorize that that's the sine of theta, then the cos of theta, if sine is y, cos gets x. So x over r. And then the tan of theta, students just memorize, and it's y over x. So again, we no longer use SOHCAHTOA. We use these 3 trig ratios here, because now we're going to be dealing with triangles, and those triangles are going to be on the Cartesian plane. All right, let's get to the first class example. So that was just sort of a review of the first two lessons. So let's do class example 1. The point -3, 2, so that's my x coordinate, my y coordinate, lies on the terminal arm of an angle in standard position. So let's find out where that point is. So x is -3 and y is 2. That would be my point there. So denote that with letter P and -3, 2. You always, once you get your point, draw your terminal arm. So get a ruler out, and your terminal arm goes from the origin or the vertex through that point. Okay? Now, if they said, well, label either your rotational angle or your angle in standard position, that would be this angle here, right? And that angle is always theta. But what we could do, once we have a point on our terminal arm, you always need to make your acute triangle. So from that point, you draw a vertical line to your x-axis, make a triangle, and label the distances of the sides that you know. So if this is -3, that distance is a distance of 3. And my y value, the length of that side, is 2. And we are going to calculate what r is using Pythagorean's theorem. So A says sketch the rotation angle. So there's my rotation angle. So I sketch that. That would be this pink angle here. And then they want us to plot point P on the terminal arm. So we did our sketch. B, calculate the length of our radius. R squared equals x squared plus y squared. R squared is equal to 3 squared plus 2 squared. So that would be 9 plus 4. R squared is equal to 13. And the radius is equal to the square root of 13. So my radius is equal to the square root of 13. Remember, your radius, that's your C on your triangle, and it's the hypotenuse. So I'm going to just double check that the square root of 13 is the longest side. So on my calculator, I'm going to type in the square root of 13. And yes, 3.06. So if this is 3, that's length 2. They are saying that my radius is a square root of 13, 3.6. Okay, so we did B. C, use these x is equal to -3, y is equal to 2, and r to write the 3 primary trig ratios. So a couple of things I need to just quickly talk about. I only take away the negative signs when I'm figuring out my radius, right? Because I can't have a negative distance. But if I was to do the 3 primary trig ratios, so I want you to redraw for C. Redraw that triangle. So here was my terminal arm. That was point P. This is my triangle here. The radius I got to be root 13. And I got y we know is 2. And x is -3. So I only am going to use like the positive values to figure out the radius, but my x I'm going to put here as -3, okay? Now, what they want me to do is they want me to write my 3 primary trig ratios. So my 3 primary trig ratios are the sine of theta, and sine is 7 yellow rabbits. So the sine of theta is equal to y over r, and y over r would be 2 over root 13. But remember, I have to rationalize that denominator. So 2 over root 13, if I multiply both numerator and denominator by root 13, the sine of theta is actually 2 root 13 over 13. That would be my trig ratio for the sine of theta. The cosine of theta, you guys remembered that cos is x over r. So the cosine of theta, x, for when we're doing our trig ratios, x is negative 3, right? So I have to use the actual point, which was negative 3 comma 2. So x is negative 3 and r is root 13. Let's rationalize by multiplying both numerator and denominator by root 13. So the cos of theta is equal to negative 3 root 13 over 13. Now, the tan of theta, tan is y over x. So y is 2 over negative 3. Those would be your three primary trig ratios. Now, I always want students to check that you're correct, and how you're going to check is the cast rule. So according to the cast rule, where was my terminal arm? In which quadrant? So you should be looking at this and you should be saying, okay, we're in quadrant 2, right? So in quadrant 2, what is the only trig ratio that's positive? And the answer is sine. So when I look at these answers here, sine better be positive, and it is. And in this quadrant, cosine and tangent are negative. So let's go to cosine and let's go to tangent, and sure enough, these answers are negative. Okay, so that's where we're going to be applying the cast rule. Okay, let's do class example 2, which I believe is very similar. The point negative 4 comma negative 2 lies on the terminal arm. So let's find out where that terminal arm is. X comma y. So x is negative 4 and y is negative 2. There's my point. So that point is negative 4 comma negative 2. Always draw that point with use a ruler going through your origin through that point. Okay? From there, we always draw our acute triangle. So from your point, go a vertical line to your x-axis. There's my acute triangle. I need to find out the radius, and the radius is going to be, this distance is negative 4, and this distance was negative 2. R squared is equal to x squared plus y squared. Remember, for radius though, I don't need to put in that negative 4 because that distance is actually 4, right? So, I mean, you could put in negative 4 and square it and you'll get the same answer. But I'm just going to put the positive value in because we're dealing with a triangle which doesn't have negative distances. So 4 squared plus negative 2 squared. R squared is equal to 16 plus 4, which is 20. And R is equal to the square root of 20. I need to see if that could be reduced or simplified. So the square root of 20 from radicals would be the same thing as 2 root 5. So my radius is equal to 2 root 5. Okay, that's what my radius is. Now, when I do the trig ratios, when I do my trig ratios, my radius will always be positive, but I need to use the values that they originally gave me. So my x is negative and my y is negative. So if I said, well, what are the three trig ratios? So the sine of theta, sine is 7 yellow rabbits, and the sine of theta Y would be negative 2 over R, which is 2 root 5. That would be the sine of theta. And then what we would do is we would rationalize this. So times that by root 5 times this by root 5. The sine of theta is equal to negative 2 root 5 over 2 times 5. The sine of theta is negative 2 root 5 over 10. And then I hope you can see this, negative 2 over 10 reduces. So this fraction would reduce. And I could divide each of these by 2, right? So if you need to, you could look on your calculator. So negative 2 divided by 10, math 1 fraction, is going to give me an answer of negative 1 over 5. So sine of theta is equal to negative 1 over 5. Or the way you should do this is say 2 goes into 2 once and 2 goes into 10 5 times. So that would be my sine of theta. If they said, well, what would the cos of theta be? Cosine, if sine is 7 yellow rabbits, cos is x over r. So cosine would be, what's my x value? On here, x is negative 4 over 2 root 5, which is my radius. Let's rationalize by getting rid of that root 5 in the denominator. And I would get the cos of theta is equal to negative 4 root 5 over, I'm just going to do this in one step, 2 times 5 would be 10. And then negative 4 over 10 can be reduced, but you could divide each of those by 2. So the cos of theta is equal to negative 2 root 5 over 5. That's the cos of theta. Let's do the last trig ratio, which is the tan of theta. Tan is y over x. Tan of theta is equal to, I'm going to go back to my triangle. Y was negative 2, x was negative 4. What do two negatives make? Two negatives make a positive. And what's 2 over 4? That reduces to 1/2. So there would be my 3 trig ratios. I always check using the cast rule. So according to the cast rule, my terminal arm was in quadrant 3. What was the only trig ratio positive in quadrant 3? That answer is tan. So then I look at my 3 answers and I say tan better be positive, and it is. In this quadrant, cosine is negative, and sure enough, I got a negative cosine, and sine is negative, and I got a negative sine. Okay? We've got 2 more class examples to go through. Okay, so class example 3. Angle A terminates in the 3rd quadrant. So now they're not going to give us a point. They're just going to tell us where it terminates. So 3rd quadrant would be right here. Okay. From here, once you get your terminal arm, you always do what? Draw what? Always draw your acute triangle. Okay. So I know that I'm in quadrant 3. And then the second piece of information they give me is this. They say that the sine of my angle A is negative 4/5. So what do we do with this? Well, what do we know about the sine ratio? The sine of angle A, so instead of saying theta, they want us to use angle A. What is sine equal to? Sine is 7 yellow rabbits. So what they've essentially given me is they've given me y and they've given me r, right? So sine is 7 yellow rabbits. So this is y and this is r. Now, they don't tell you where that negative goes, and you have to just be able to think about this and rationalize this. Where would that negative go? Which one of these could never be negative? And that answers the radius. So I know that my radius is 5, therefore y is -4. Okay? So, and that makes sense, right? If you guys think, if I said, well, in quadrant 3, what would my y values be? All of my y values in quadrant 3 are negative. So what are we missing? We're missing what x is, right? And we're going to need to solve x. Okay, so how do we do that? We're going to use our formula. R squared is equal to x squared plus y squared. And I'm going to manipulate this formula to get x by itself. So I'm going to subtract y squared from both sides. And x squared is equal to the radius squared minus y squared. So to figure out what x is equal to the radius squared, which is 5 squared, minus r squared. And r, remember, because we're dealing with a triangle, I don't need to put -4 because we're dealing with a triangle. So I'm just going to put -4 squared. X squared is equal to 25 minus 16. X squared is equal to 9. Now, if I square root both sides, I get x is equal to positive or -3. But you have to ask yourself, in this quadrant here, what are my x values? So if I go to the left of the origin, what would this distance be? Like, what's that x value? So if I go right of the origin, x is positive. If I go left of the origin, x is negative. So my answer is x is equal to -3. Y is equal to -4, and radius is equal to 5. Okay, so in this quadrant here, x is negative. Okay, then it says using the values of x, y, and r, so I've got it labeled x is -3, y is -4, r is 5, determine the exact values of the cos of A and the tan of A. Okay, so cos of A, I'm just going to write sine of A off to the side, because sine of A is 7 yellow rabbits. Cos of A, if sine is y, cos is x over r. So the cos of angle A is x, which is -3, over r, which is 5. That would be my trig ratio for the cos of A. What is the tan of A? So tan of A, tan is y over x. So the tan of A is equal to, what was y? -4 over x, which is -3. If you were in class and I said, okay, what's -4 divided by -3? What's two negatives? Hopefully you would say that makes it positive. Tan of A is equal to 4 over 3. How are we going to check this? What would you guys say? How would we check this? We would check this according to the cast rule. And according to cast, we are in quadrant 3. So my terminal arm is here. What is the only ratio positive in this quadrant? Tan, T. So I go to my answer and I say, yes, tan is positive. I did that right. Then I go and I say, well, what was cosine and sine in this quadrant? They both are negative. And sure enough, my answer for cosine is negative. Okay. Rewatch that video if you're unsure, but class example 4, which we'll now do, is very similar. Okay. So the tan of theta is equal to -2 over 3. So they're not telling me what quadrant this is. We have to use our cast rule. So here's what we're going to do. What you're going to do is they're telling me that tan is negative, right? This ratio is negative. So according to the cast rule, what I want you guys to do, so write down cast, put a check mark in the quadrants where tan is negative. So they're telling me that tan is negative. So go ahead and put a check mark in the quadrants where tan is negative. If you did it correctly, you should have 2 check marks. That quadrant tan is negative, and this quadrant. So in quadrant 1, tan's positive, and in this quadrant, tan's positive. Tan is negative in these 2 quadrants. Then what they say, so I know tan has to be negative. Cos, they're telling me, is positive. Okay, my answer is either this quadrant or this quadrant, right? Tan is negative in these 2 quadrants, but I have to pick between these 2. Where is cosine positive? And my answer would be this. There's only one quadrant where tan is negative and cosine is positive, right? So from these 2 quadrants where tan was negative, the only one where cosine was positive was this guy here. So my answer, or my terminal arm, is going to be in quadrant 4. Let's draw our triangle. So draw a point on your terminal arm, go up to your x-axis, and draw your acute triangle. Now, tan is equal to, what was the ratio for tan that I said you have to memorize? Tan is y over x, right? So I don't know where that negative goes. I'm going to have to think about it. But y is 2 and x is 3. So y is 2 and x is 3. I would say if we were in class, okay, how many of you could look at this and tell me where does that negative go? Does it go with the 2 or does it go with the 3? Well, my x, if I go right of the origin, is positive. My y would be the one that would be negative. So that negative actually goes with the y. Okay, so I hope everybody could see that. And then what it says is, the question is, find the exact value of the sine of theta. Okay, sine of theta is, sine is 7 yellow rabbits. So in order to do the trig ratio for the sine of theta, I need to know what r is, right? I know what y is. Y is negative 2. I need to get r. So I'm going to use Pythagoras' theorem to get r. R squared is equal to x squared plus y squared. R squared is equal to 3 squared plus 2 squared. I'm not putting in the negative 2 because I'm just dealing with the triangle, and I'm going to do my distance. Okay. R squared is equal to 9 plus 4. So 9 plus 4 is 13. And then r is equal to the square root of 13. And remember that we're dealing with radius, which is always going to be a positive distance. So I'm not going to write plus or minus, right? Because my radius has to always be positive. So if sine of theta is 7 yellow rabbits, y over r, I could now figure out what the sine of theta is. Sine is y over r. Would you box this in? Do you think you're done? The answer is no. We got to rationalize. So let's multiply both numerator and denominator by root 13. And the sine of theta is equal to negative 2 root 13 all over 13. Now, what would I say you should check? Every single question, what do you check? And that answers the cast rule. So I always redraw cast at the end of my question. And then I say, okay, the question was in quadrant 4. What was the ratio that was positive in quadrant 4? The only trig ratio in quadrant 4 that's positive is cos. So my sine ratio should be negative, and it is. That's going to be the end of the lesson. I want you to do all of these questions, which is a lot. So take your time with them. Those of you that want to keep watching, I'm going to set up questions 4, 5, and 6. So if you get sort of stuck on questions 4, 5, or 6, I will set those up for you right now. Okay, so question 4, they give me the cos of theta. So what I want everybody to do is draw your Cartesian plane, right cast, and please put a check mark. So ask yourself, is cos positive or negative in right with this ratio? And it's positive, there's no negative sign there. So put a check mark in the 2 quadrants where cos is positive, right? Because this trig ratio is positive. If you did it correctly, your 2 check marks will be in quadrants 1 and quadrants 4. Those are my 2 quadrants where cos is positive. I need to narrow down my answer to one of these 2 quadrants. And how I'm going to narrow down the answer is this statement right here. They're telling me that theta is less than 360 but greater than 270. So what does that mean? Here's 360 degrees. Here's 270 degrees. They're saying that they want my answer to be less than 360 but greater than 270. This is telling you where they want the angle to terminate, and I hope you see that from this first trig ratio, we were either in quadrants 1 or 4, but then this statement here, which is my domain essentially, is telling me that they want my answer to be in quadrant 4. So my terminal arm is in quadrant 4. From here, draw yourself your triangle. And now I'm going to label my triangle. They told me that the cos was 12 over 13. And if you have cos memorized, cos is x over r. So x is equal to 12. And r, my radius, is 13. So from here, before you could write the trig ratios of sine and tan, you need to figure out what y is. So r squared is equal to x squared plus y squared. To isolate y, so to get this guy by itself, get rid of the x squared. Y squared is equal to, what would it be? R squared minus x squared. And you would figure out what y is. So 13 squared minus 12 squared, y squared is equal to, so 12 squared minus 13 squared is 25. Now, this one you have to think about is why, when I square root it, am I going to take the positive 5 or the negative 5? So in quadrant 4, what would your y value be? And all of your y's in quadrant 4 are negative. So my answer would be y is equal to negative 5. Now you could do these 2 trig ratios. So sine of theta is 7 yellow rabbits, y over r, and tan is y over x. Let's figure out where my terminal arm would be for question 5. So draw yourself a Cartesian plane, right cast. Please put a check mark in the 2 quadrants where sine is negative, right? According to the cast rule, where was sine negative? And you should get quadrants 3 and quadrants 4, a check mark there. We're only going to, in 20-1, our answer is only going to be in one of these 2 quadrants. So then you look at this next statement to find out, do they want my answer to be in this quadrant or in this quadrant? So they then say cos is negative. So within these two quadrants, where was cos negative? And this is where cos is negative. So my answer for this question, we are going to be in quadrant 3. That's where sine is negative and cos is negative. Okay? You would draw yourself your acute triangle, and let's label it based on sine. So sine is 7 yellow rabbits. So y, I'm going to put a 4 here, and I'm not going to put the negative just yet. I'm just going to put a 4 there. And my radius is 7. Where would that negative go? Does it go with the 4 or does it go with the 7? And you should say, okay, my radius has to be positive. My y values in this quadrant are negative. So the negative goes here. And you guys are going to use Pythagoras' theorem to figure out x. And x better be a negative number, right? So make sure you get x is negative. Last question I'll show you. According to CAST, put a check mark in the two quadrants where tan is negative. So where is tan negative? Here and here. Then my solution, they're saying, is my angle is less than 180 degrees. So here's 180 degrees. So less than 180 would be that. And greater than 0 would be, if this is 0, they want my solution to be in here. But according to this first one, I know that I'm either in quadrant 2 or quadrant 4. If I restrict my domain, my answer is going to be in quadrant 2. There's my acute angle. Tan is y over x. So y is 15. So that is 15. And they're saying x is 8. Now, which one would be negative? Does that negative go with the 15 or does it go with the 8? Here in this quadrant, my x's are negative. So that negative goes here. Use Pythagoras' theorem to figure out what r is, and then do these two trig ratios. Make sure you check your answer using the cast rule. So in quadrant 2, sine, you better get a positive answer, and cosine better be negative.